purpose of this video is to demonstrate how to analyze the reactive oxygen species data that we get from Ocean View. If you've worked or seen it in the lab, one of the things you'll notice that software is not super user-friendly. And so we choose to do our analysis in a completely different software known as Pasco is the company and Capstone is the title of the software. You can get this software by going to their website. You can just use the website in the toolbar up there, or you can Google Pasco Capstone, and in it you'll actually see the link for the downloads, and you can pick either the Windows or the Mac version that best fits your computer. Once you have the software, I think there's a trial, but reach out to me and I can give you the full license in order to have the full version. So I have an unlimited license code that I can get you so you can do that. Once you have the Capstone, you are ready to start data analysis. So first let's jump to the template of what we're going to fill out. Note that these template folders, I usually try to put one of these files in with the data that you're going to be analyzing, so check the folder that I've given you to analyze. We really need only a handful of things. The first thing you should always start with is writing the complete file name of the data. Sometimes these can be long, depending on how they were saved, so you can copy and paste that from the folder, or you can just type it in. We need that because depending on how it's all set up, at some point once we get this raw data, then we'll actually convert it into what data matches what animal and what tissues, and so the file name is critical in us being able to do that in the next step. What you're going to see is we're going to primarily be looking at the slope. So we're going to look at the slope of two different lines. And what I'm going to ask you to do is record the slope, the y-intercept, and the r squared value that will be given by the program. When we look at the data, this will make more sense. So I have them color-coded. There's two different curves that you're going to look at. You're going to look at the first part of the curve, which is relatively flat, and then the second part of the curve, which is significantly steeper. And you're going to write this data into notes. So now that we kind of have an idea of the program we're going to use and the data that we need to collect, let's jump into understanding how to analyze the data. So here's an example folder of something that you might see for data collection. Again, in the folder I'll show you there's a data template. That's where we're going to put in our slopes. You're going to see our ROS graph template. This is what we're going to open in the Capstone app. And then the way that I typically record data is based on date, and then you would see all the file names in here. So let's open this Capstone app. So it'll open. And what this does is this sets up our layout that you'll basically just need to recreate. To kind of work you through, what we're going to see here is a couple things. So on the left side of the table here, this is our x-axis. So in our measurement of ROS, we're going to look at the x-axis as time, and ultimately we're not really caring literally what time it is, just each consecutive measurement. And so I've set up the x values already here. What we need to get is the y values, and the y values can be found in the text files with the graphs. Again, these are in the folders in which I've given you, typically organized by date. So what we want to do is open one of those. So I have one already opened. Again, when you open them, they will typically come in a notepad format and look something similar to this. There may be some slight differences in this, just based on the type of machine that's recording and who's recording it and how they exactly save the data. But the first thing that we need to do is copy all of this data. So you can go to Edit, Select All, or as you saw the keyboard shortcut of a Control-A to select all the data, and then you can copy it by hitting Edit Copy, and then, or you can hit Control-C. We'll come back to Excel here, and then we'll paste. So we'll paste our values here. So you can paste or you can hit Control-V, either one. So what we'll see is potentially some data on how everything was collected. We can ignore that. And then we have 3 columns, and the important thing that you want to note is our data comes from this far column here. What I'm doing now is I'm going to select that column. You're going to notice we collect a lot of data points in this software, and so we're going to have a relatively large number of data points. So we'll scroll all the way to the bottom, and you can see we're at 4,000, closing in on 5,000. Still going. Taking longer than I expected. Alright, so over 10,000 data points. So once we get those selected, again, you can copy them as you go through. One of the quick things I'll note, so there's a duplicate copy, there's a top and a bottom. I'm moving really fast so you can't really see that. The data should be the same. Not all data files will have it. Typically, if you autosave with the program, it'll create 2 files. If you save it as a text file, it won't. So either way, the data looks exactly the same. So we've copied that entire column, and now we'll move over to our program and we'll paste them. Depending on the speed of your computer, how new it is, and the processing power, this may take a little bit of time. It may take 15 seconds at most, but shouldn't be terribly long. This is, as you can see, one of the longer parts of the actual analysis. Alright, so once you've got everything copy and pasted, you should see a figure that looks something like this. Again, you can use your mouse. Some of this will take some time just practicing, kind of playing with the program. But what I want you to notice is there's a flat line here and a steep line here. So we want the slopes of both of those. Before we move on, I do want to make one quick comment. So when you look at our X and our Y, so depending on the file size, I tried to set this up to be set up to never run out of space. So I think I set up the X column with 20,000 data points, so we can jump down to the bottom. So almost 20,000 data points. So as long as you have less than 20,000 data points, this will work. If you have more than 20, you need to add numbers in the X column. Again, I don't envision there being a reason why you would have more than 20 data points in your file, or 20,000 data points, but just as an FYI. So we have enough space. If you have excess data points on the X side of things, it doesn't really matter. It only plots when there's an X and a Y. So we have everything saved, everything copied over. Now we need to get these slopes. So this one is relatively straightforward. So if you can see the red box here, so what we're going to do is we're going to use these red boxes to zoom in to the zoom in on the lines. So when we put the red box in them, what you'll quickly notice is the red box will give you the slope of the data point. So here's all the data that we need. So one of the things that that we asked or that may not make super sense is there is some objectivity to this. You should be able to have all the data points, but it's also subjective. You also want to kind of look at this data and see. So you can see this red line is the slope, and you want to see that that mostly matches. This one is a relatively easy one. Again, if you see if I added this in, then that line might get on the kind of wonky side of things and might not perfectly match up. And so what I do is just try to get a line that fits here as we go through. We then have our line, and here's our line of best fit. So we'll go in and we'll type those values. So I'm not going to do it here, but we would type in our slope, which is our M value, 1.44, our y-intercept, or our B, which is 13,400, and our R, which is 0.979. We'll do the same thing for the second half of the curve. So we'll take, and you can, as you kind of watch me kind of play around, you can use these red boxes and you can change the shape of them by grabbing the corners just as if you were drawing a figure or something in PowerPoint or Excel. So again, you can see just kind of clearing out, moving space, getting a bunch of data points here. So again, we're going to click on it, we're going to see that line. I think that line very much fits. What I will note is you want to ignore this part of the curve. So this occurs when we open the chamber in order to add succinate in. So the light coming in gives a wonky reading. Then we usually get some type of kind of exponential looking curve, and then it becomes linear. So we only want to measure the slope when it is linear. And you can see my red box as we draw around that is avoiding any of those data points. Again, we have our slope, our y-intercept, and our R value. Once we have that, we can move on to the next sample. So in order to do that, one of the things that we've learned is that we just need to replace these y values. It is possible to just select the y and hit delete. However, this, depending on how many data points, let's say if you have 10,000 data points, it actually takes a really long time, like 10 minutes or more to do that. And so the workaround that we do is we just reopen the template with it blank in order to speed up the process. So go to File, Recent Experiments. I opened the same one that I have open. The key is you don't want to save it. You want to discard it. So once you discard it, you open, we now have our X and our Y, and we're ready to copy and paste the next experiment. Again, relatively straightforward there. I'm going to pause the video, we'll come back and I'll show you some data samples that aren't so obvious when we can't just kind of take the big red box, put it around it, and get a slope immediately, that we actually have to delete some points. So let me find a good data set that shows that, and we'll be right back. Alright, so in a perfect world we wouldn't get data that looks like this, but sometimes that happens. So what we'll see here is our baseline slope down here is just as one would expect, but our next slope looks really funky. So what usually causes this is the fiber inside the quartz vial starts bouncing up and down and causes a whole bunch of noise. One of the things that you can kind of notice is all the noise goes like up in one direction, and so it really skews our results. So what we need to do is get rid of or delete those data points. Again, as a scientific general principle, you never really want to delete data points, which is the second really big pro of this software here. So what you're going to see me do, we'll start out relatively simple. I'm going to take my big red box and I'm going to highlight most of the data points. As you can see, my computer is struggling to keep up doing the video recording and this as we go. What you can look, and yours may be smaller depending on kind of where you're looking, but what you can do is you can kind of find this little blue line and it's got a black mark over it. So if we click that, you can see there in the yellow what it says is exclude the data in the highlighted area. So I'm going to click that and then click exclude the data. So what you're going to see is the program will think. Again, mine's running a little bit extra hard right now with the video recording and all the stuff kind of added, but it's going to think and these data points won't be included. What you'll notice here is though it's still not going to work super well. I'm going to need to zoom in here really well in order to get a much better value here. So we'll pause, and once this comes back, we'll zoom in and show you how to do that. Alright, so as you can see, the data points have now become an X, which means that when we kind of highlight them and select them, we won't be they won't be contributing to the line of best fit. So even though we've deleted out a large number of these data points, the slope really isn't something that we can identify here very well. and indeed we need to get out a much larger amount of these data points. One of the things that will entail is zooming in or zooming out. So you can do it a couple ways. So here we can just zoom in using our keyboard or mouse. So for me, obviously you can't see this, but on my mouse I'm just using my wheel to spin out. We can also zoom in here. So you can right click and you can let's see, so we can do axis properties, and we can look at our scale here to kind of give us an idea. So this will tell us where we are on the axis in order to kind of zoom in. So honestly, this one's going to take a while. So again, I'm going to follow that same process here. I'll note as you can tell, my computer doesn't really love me recording video and isolating this. So what I'm going to do really fast is I'm going to do this one more time. So we're going to zoom in and get more data points. We'll click here and we'll exclude highlighted data. I'm going to pause the video, get this cleaned up kind of how I would want it, and then show you the final product because again, as you can see, my computer is going to lag really, really heavily as we continue to do way too much stuff on it. Okay, so I've tried to clean this as much as I can, but I would note for you, I would encourage you to kind of chop out as many of those points on the high end and then maybe a couple here on the low end to be a little bit better. But nonetheless, this can give us a really good demonstration of what we ultimately want our data to look like. Because what I want you to do is kind of take a look and make sure that this red line, so you can see the line that our slope is running behind there. And I want you to see if you feel like that slope is matching with the data points basically visually. I want you to look at this and say, if I drew a red line, how would I draw it? And if it's similar, then you would continue. Is this, I would say, I almost feel like the slope is a little on the low end. So I would, I'm going to kind of move my box here and see if I can't get a higher slope to kind of match what I think more looks like in that curve. So after doing that, I feel like that's a really good curve there, and then that'll give us now our slope. Alright, with our slope now, again, as I mentioned, we can transfer this over. So in this case, this would be our slope in our succinate or state 4 respiration. So our slope would be 2.13. So we'll come here, we'll say 2.13. Our y-intercept is 18,500. And our R is 0.869. So once you have that, again, the concept we would do is after we've got our data, then we can just go to recent experiments and open up the file. Again, so I would open, we'll discard, we'll get that empty data set over here as we go through, and then proceed to analyze the next values.